Okie dokie, okie dokie. Couple of exercises. I want you to try these. AN is root n over n. There's one. And B will be AN is this awful looking thing. Okay, I want you to pause and give that a shot. Think, try. And here I come with some answers. Solutions, rather. Okay, first one. AN is equal to root n over n. Now, if I simplify that, that's n to the 0.5 over n to the 1. And subtracting exponents gives me n to the negative 0.5, which is 1 over n to 0.5, 1 over root n. Okay, with practice, you can skip right from here to here, but there are the details. Okay, now I see I have 1 over something that's going to infinity. So the limit here is 0. Okay, I got a real number, so it's convergent. But if you want, you can write the word convergent there as well. Okay, B. Let's just copy it out again. Okay. So this is one where I'm going to have to simplify again. Because I notice that the limit here is infinity. Okay, it's 2 to the power of infinity, if you want to think of it that way. And here you have 6 to the power of negative infinity. So because it's 6 to negative infinity, the limit here is 0. Okay, so it's an indeterminate form. 0 times infinity is a very difficult thing. So we have to simplify to make it easier. So I get 6 to the 1 over 6 to the 2n. Like so. It's my first step. It's 6 over, this looks like 36 to the n times 32 to the n on top over 2. Giving me 6 over 2 is 3 times 32 over 36 to the power of n. Let's reduce that fraction. Reduce that fraction. Divide top and bottom by 4. 8 over 9. Now, as I mentioned before, 8 over 9 is between minus 1 and 1. So this limit here will be 0. Okie doke. I want to talk briefly about something that's close to my heart. Let's look at part A again. You don't have to write this down, but I just want you to be aware of kind of another way of doing this part A here. You notice I didn't write the word lim anywhere in this solution. Okay, let's do it again with the lim. Lim, so that's lim 1 over root n. And now here I can see quite clearly that the limit is 0. Maybe the first time I'll put in n goes to infinity here. Not really necessary, because when we're talking about sequences, it's always lim n goes to infinity. So there's no ambiguity if I just drop this n goes to infinity here. Okay, what do I want to talk about? Okay, so right here and right here, two different solutions. Either one is fine. Okay, but what you cannot do, you can't do something like this, where you go an is root n over n, which is 1 over root n. And then for some reason you tell me that this is 0. So what I want to say, this is good, this is good, this is not good. Okay, why is this last one not good? Well, where's the problem? Well, the problem is a very glaring issue right here. That equal sign is not true. So I'm going to be a stickler for this, because equal signs that are false are not okay, unfortunately, in my book. So watch out for that. Okay, if you want to fix this, if you find yourself doing this, and maybe you say, oh, I don't want to waste time and erase it and do it all over again, well, you can just go and just write a little L here, just to indicate there's a limit, there's a limit, there's a limit, and now it's okay. Okay, because the limit of 1 over root n is equal to 0. But if you don't have the limit in front, what you're asserting is that this fraction is equal to 0, which is not true. Okay, it doesn't matter what n integer you choose here, this fraction is not going to equal 0. But if you stick these limits in here, just as scripty L's, it'll be a-okay.